Alright, welcome back to the SciMax Electronic Lab Notebook channel. Today I'm going to show you some ways we can give Claude Code some new skills for research, and that basically means we're going to create some markdown files that tell Claude how to do certain tasks that it doesn't otherwise know about. So you do this by creating a skills directory in the .claude that's going to be created right away when you launch Claude. And inside there will be directories, one for each skill. And I want to tell Claude how to run the Claude-Light instrument. And so inside here we have a skill.md file. And what this is a markdown file with a YAML header. Claude Code reads these YAML headers, and that's all it keeps in memory until it decides that it's time to use a skill. And then it finds ways to read the rest of the skill to learn what it can do. So the rest of this file just has information about what Claude-Light is, where it's accessed, information about the hardware, various interfaces that you can access, the API, what kind of outputs you get, and some basic measurements you could make with Python. This is a file that was generated by Claude by looking at the website, the GitHub repo for Claude-Light. So this is how Claude will be able to figure out how to use the Claude-Light instrument when we prompt it. There's also a pycse skill. This is a specific library that I wrote for doing a lot of things that include design of experiments and analysis, and here it has access to all the functions that are available and things, examples of how to use it. And Claude Code can already read the repo that's present, but this helps it get where it needs to be. And then lastly, I have this ELN, which is the Electronic Lab Notebook, and this is an experiment to see if I can get Claude to write better notes that are better organized and more suitable for analysis later. Alright, so that's just what you see in the .claude directory, and we'll get back to the main idea here. So what will happen now is I'll go over here and launch Claude. And I have it set to use Haiku 4.5. That's the new fast model. Hopefully, we're not doing anything tricky here, so hopefully that will make it kind of fast. I can ask it to tell me about your skills, just to make sure that it has read those files and has some, and that they will be available. And so you can see here it finds pycse, Claude-Light, and ELN, and litdb is a different skill that is installed in the global system-wide Claude Code. And then now I can just say run an experiment on Claude-Light with r equals 0.5, and then run 3 other settings too. And then I ask it to document it as a proof of concept test. So now let's see what happens if I do Control-O. It is running a proof of concept. It's using the Claude-Light skill. It's going to use the to-do right to organize and make sure it's got to do multiple steps. So it's going to write a script, collect data, document results, and at some point it says, do you want to create this proof of concept experiment.py? So it's choosing to write a script, and it's quite verbose what it does, but these are the experiments it's going to run. And if you're happy with the script, you can say yes, and then there goes red, maybe green, blue, and white. And then I saw a little image pop up. I think it graphed something. Let's see what we got. So this one shows a figure that it made of one, and then this one shows the spectral signature. So red has the highest at 630, but you see some neighboring bleeding. 515 for green, clear is hitting all of them, and then blue is 445. So that seems pretty nice. It made some figures, and now it's asking, do we want to make this org file? Let's just say yes. And now it's going to commit those results, and probably I need to, this is going to commit in a different Git repo that the whole journal's in. I guess that's okay. It'd be better if there was a local Git repo. And let's see what we get here. Let's look at our org file. So here is the day we did the experiment. Here's the objective that it claimed. It wrote down materials and methods to fix this. We have these test configurations. This is the script that it ran. That's nice, although I don't like that it's separated. We have a data file, and here you can see the images that are present, and it's pretty thorough. Maybe too thorough, I don't know. Let's go back here and try one more. Let's do something kind of more sophisticated and design a surface response experiment for RGB in this range. I'm going to tell it to use the pycse skill, mostly because I've tried this once before and it didn't use the pycse skill, either because I didn't load it right or something, or it decided it could just build its own because it's seen this kind of stuff before. So I think it's always a good idea to be specific when you know what you want to make sure you get it. And so now this is probably also making a to-do list. It's creating a Python script, and that's what it is doing now. So that Python script will have the actual design somewhere. Let's see, what is it doing? It's got some functions. I didn't specify what kind of design, so it looks like we have CCD. So this isn't actually using pycse. This is creating its own design, which you may be okay with, but that's not actually what I want. So let's say no. And so I say 3. Use the box Bankin design from pycse. Let's see if that does it closer to what I want. Okay, this is what I want. I want to see this particular code. Alright, so that's still not doing quite what I want. One more try. this looks like it's doing the right thing. We get our surface response task. The other ones could have been fine, but this is one that I've come to, I wrote and created. We have the design type. We have the design, then we convert it to this, and all right, let's see if we get what we want. It's not obvious that's going to run any experiments. That may come next. You can see here it's actually reading from the source code. Let's see what it puts out. Okay. While that's chugging along, let's see what we get over here. We have the objective, design, surface response. This gives you some comparisons and why we made our choice. Maybe this isn't all super necessary. Let's see, do we want to execute this? We've got Claude's making some measurements, running some experiment. It's going to read a design file that is defined up here. So there should be a CSV file. Let's just go YOLO. This is only going to run an LED. It's not going to cost any time or money. You can see it starting to blink now. So it's running all of the points. Meanwhile, we'll look what's going on back here. You can see the whole design, what it calls, the edges, some figures about where the experiments are. It does sort of estimate. This is 11 seconds of time. That's kind of nice. It talks about the model. And this is annoying. These are markdown, not org mode. Guess it's not perfect, and it has some references to where you could find some information. So now let's run the experiments. Let's see, what is it doing? Now it's creating a report. Here's our analysis of variance data. I think it's important to note this is being done by calling functions and not just generating analysis. So we'll save that. That's going to be in a new file now. So here it's going to highlight the things that are significant. There's a green one, a red one, and blue. Interesting, this one is like a little less significant than that. Lots of statistics that may or may not be super meaningful to you. Have some factor effects, heat maps of what things matter, good reproducibility. Okay, let me make one more. I like to see a parity plot. Let's see, it's good. I don't know why. I always like to see parity plots. I know they can be misleading, but seeing the numbers can also be misleading. So I like to see good numbers and good parity. Let's see. Here's parity, all wavelengths, those look great. Look at all of these lines. Everything's linear. Everything looks perfectly reasonable. And a little bit of noise for clear. That's not too surprising, I guess. Great. And so we'll just add that to the analysis of variance org file. And that's going to bring me to nearly the end of giving Claude Code some new skills for research. I think you can use this kind of method for Codex and probably for Gemini. Some people call these things agents, but they are at the end here just a markdown file. It's a little bit different than the MCP server that you can also use to connect to Claude-Light. That's giving a set of tools. Here we give a set of information that tells Claude Code how to write code and how to run command line tools, and then that is a different approach. So overall, I think it's pretty exciting that you can, with 20 minutes here, figure out how to get a surface response experiment that is designed, the experiments got run, the ANOVA was done. You still have some work to do to go through and make sure the results make sense and that the analysis is meaningful, and what you do with it after that is up to you. But now you have, if this would have previously taken an hour to do, you now have 40 minutes to focus on thinking about whether the experiment was done the right way, is the fit good, et cetera, where before it might have taken an hour just to get to this place, and then you could think about those things. Obviously it wasn't perfect. It did take a couple of iterations to get the design right, and I concede at this point these experiments are so cheap, you kind of can't go wrong if you ran them all kinds of different ways. But that gives you an idea of what is the challenge ahead in using a tool like this. If those experiments took all day to run, you would want to be very careful at the very beginning to make sure it was set up the way you want, and that you didn't have to go back and repeat it tomorrow. And that's going to eventually mean you take much more time than this short demo video of how it works. But otherwise, that's all there is to adding these skills, and there's some more details for skills that you can have sub-skills and other documents that expand the capability. But for today, I think we've demonstrated the utility of having a skill. Thanks for listening. See you next time.